Hi, let's talk about a very famous and prominent curve known as bell curve. The bell curve is also known as normal distribution. Now, the shape of this curve itself gives us a hint that why it is called as bell curve. Uh, let's go into the details. So here, as in any graph or curve, we will have one x-axis. In this case, the x-axis will be your data of interest, and the y-axis would be the normalized values of your data. Now, what are the normalized values? It is the scaled value of your data where the scale range will be within a range of 0 to 1. How do we find it? We will see in our subsequent discussion. So, it is pretty clear that the shape of the curve is bell shaped. The exact center of this bell curve would represent the mean, or you can say the normal value. The extreme right of this bell curve represents very high optimism, whereas the left side of the mean would represent pessimism. Regarding normal distribution as a name, distribution in this represent nothing but the laying out of your data around the mean of the data. Normal, why do we call it normal, is because we are normalizing the data before we represent it on a graph. Let's take an example where we can apply this bell curve to infer some insight from the data which is available with us. So say for example, you have data for the PE ratio of a exchange for the last 3 years. With this data, if you want to see whether the data presents any enthusiasm, pessimism, or a norm, first and foremost, we need to find the mean of the data, which can be found by using average formula in the spreadsheet. Later, we need the standard deviation for this data. In this case, we are going with dot p means population, because the data of 3 years represent the entire population of the data. Once we have these two things in place, mean and standard deviation, we will do a normalization of data again by using one more readily available formula in spreadsheet, norm.distribution, which requires mean and standard deviation, and that is why we have calculated them in advance. In this formula, if you see, it needs the data point. In our case, let's choose the first one right now. After that, it requires the mean value. Do make sure that the mean value cell's name is having dollar sign, so that when we drag and drop the formula will always refer these cells. For standard deviation, we will do same thing what we did for mean, and finally we need to choose a value called as false. So the normalized value for this particular PE value is almost 0.17. Just drag and drop till the bottom so that the values for the entire data set are normalized. Now the most easiest part is just choose your data of the PE or your actual data and the normalized values, and under insert go for a scatter plot in order to create the bell curve. Here if you see the initial starting value from 0 to almost 17 do not exist in the original data, and that is why it is not being shown in the graph. So we can quickly revise the range so that the graph becomes more prominent and clean for us to analyze. So here if you see, the mean of the data is 26.7. The right side would represent excessive optimism for buying the stocks at a high PE ratio, and the left side of the mean would represent excessive pessimism. As of today, in September 2020, the PE ratio is at almost 33, which is lying at the most extreme rightmost side, and one can infer that as of today the market participants are pretty optimistic about the future of the index stocks. So stay tuned for similar videos where we will cover basics